Alright, so here we go for 10.2. We're going to be looking at describing the characteristics of a sampling distribution between the difference of two means. You're going to calculate the probabilities. We have to determine whether conditions for performing the inferences are met. We're going to use a two-way sample T procedures to compare two means based on summary statistics or on the raw data. You're going to interpret computer output. Okay, this is a big one, making sure you can read the computer output. You're going to have to perform a significance test, and you're going to have to interpret the results. Sounds really complicated, but it's really not. You know how to do it all, I'm pretty sure. All right, so we're already looking at two populations. Now our parameters of interest are going to be mu of group 1 and mu of group 2, which means the population mean of group 1 and population mean of group 2. We want to compare the effectiveness of two treatments in a completely randomized experiment. We would use the parameters mu1 and mu2, okay, their mean responses in treatment 1 and treatment 2 respectively, and use the mean response in the two groups to make a comparison. So what you're going to end up doing is having population group 1 and 2. You'll have your parameter, so you'll have your mean of the population of group 1, your mean of the population of group 2. You'll have your mean of your sample from group 1, and your mean of your sample from group 2, which is your x-bars, and then you're going to have your sample size. What you're going to have to notice is that a lot of times you have different sample sizes, okay, for the two groups. So there's a good way to keep everything organized is to write it down. If you don't, you'll confuse yourself. In Chapter 7, we saw sampling distribution of sample mean have the following conditions. Remember, if my sample size is large enough, then it's normal according to the central limit theorem, or the population distribution is already normal. The mean of my sampling distribution is the mean of the population, and that the standard deviation of my sampling distribution then takes the standard deviation and divides by the square root of n. Are we going to have the standard deviation of the population? No, we are not. So we're going to use what in place of this sigma right here? What are we going to use? We're going to use a little sample. So this is going to become sample. And when I put sample standard deviation in there, what does this become? Becomes the standard error of the means. Some of you forget that because you didn't do that right on something I graded recently. Not sure. Okay, so once I put an S in there, that becomes the standard error of the mean. So I take the standard deviation of the sampling distribution and use it and divide by the square root of n. So to explore the sampling distribution, the difference between two means, we're going to look at two normally distributed populations. And they get this information from the United States National Health and Nutrition Examination Survey. And your nurses do this. I think like as freshmen, I think it is, they make you go down to the gym and they like do everybody's height and weight and all that stuff. It's for this thing right here. And so based on that information, they let you know that the girls follow a normal distribution. So this is important information. They follow a normal distribution with a mean of 56.4 and a standard deviation of 2.7, and then the boys follow a normal distribution with a mean of 55.7 and a standard deviation of 3.8. They tell you that they take a simple random sample of 12 girls and 8 boys of this age and measure their heights. All right, if this is a real problem, and I would be a little worried about the sample size, but they tell you that the population is normally distributed, so you're okay. All right? So if they didn't, then we'd have a problem because our sample size wouldn't be large enough in order to assume this central limit theorem. Everybody notice that? So one thing I always clue into is my sample size when I'm looking at it. Technically, this would be too small if we didn't already know that the population was normal, which is what they tell us. Otherwise, I'd be having issues with this being 12 and only 8. They want to know what can we say about the difference in the females minus the males in the distribution. So when they look at it, this right here is a sampling distribution for females, and they tell you the shape is normal, the center is at the 56.4, which they stated. And then notice they go ahead and take that 2.7, which was the standard deviation, and divided it by the square root of 12 because that's how many girls they took. And they got the standard deviation of the sampling distribution to be 0.78. That's what they're telling you here, and this is the picture of it, because they said that they used Fathom to reproduce it 1,000 times. They did the same thing for males, all right? They got the center, which is 55.7, and then again they did the same thing for the standard deviation and found that it was 1.34 inches. When they want to know about the sampling distribution of the difference in the two, the females minus the males, all right, they got these two values right here, this 0.7, and that the standard deviation is 1.55. So from Chapter 6, you probably already remember that all we had to do is take the girls, which is 56.4 for the mean, and subtract the boys, which is 55.7, and that's how they got that 0.7 inches. You can just subtract the mean straight, but can I do that with the standard deviations? No, I can't do that with the standard deviations. All right, and so that's what they're explaining to you here. For the mean, I can just subtract them. That's what Chapter 6 told us. Okay, and then when this is really the variance because it's squared, so if I wanted the standard deviation, I'm going to have to take the square root of it. And they're showing you how they got these values. Because this is the standard deviation of group 1 squared, so it's really the variance, and that's how you get that. This is how I found the standard deviation of group 1, and then I have to square it to make it this. Everybody see that? And they do that for group 2. Right? So then they just get the square roots on the bottoms cancel out, and they just get the variance over the sample size plus the variance over the sample size. But then in order to get the standard deviation, they have to take the square root of the whole thing. They're showing you where that formula came from. Everybody understand where the formula came from? And so then this formula right here is on your green sheet. This is on the green sheet for the difference. Notice that even when we had to find the standard deviation of the difference between two things, we still added in the middle. Yes? Everybody notice that? That would be fabulous. All right, so here they summarize it for you. So the standard deviation of sampling distribution between these two is this formula right here, which is on your green sheet, guys. This is on your green sheet. You don't have to memorize it. All right, green sheet. So don't be like, oh, I don't know, I don't remember. Guys, it's on your green sheet. That's why sometimes I want to hurt children, because they just don't listen to me. You know.